Today we are going to start our unit on quadratics, and the first day is different forms of the quadratic equation. Any equation that is degree 2, which means it looks something like this, with a little squared by your variable, usually x, and I'll just fill in the rest. This will be the linear term, and this will be the constant term. But the degree is the biggest exponent of any term, basically. And since that's 2, that's called a quadratic. And I know quad seems like it's 4, but quadratic actually refers to any equation of degree 2. And you might have seen some of these before. You might have worked with them. You may know a lot about them. But this is where we're going to start today. I'm going to give you another couple of examples of the way a quadratic equation might look. Here's another one. Okay, this would be called factored form. The first form, it's called standard form. All right, and a lot of times we would express this as y equals ax squared plus bx plus c, just to kind of give names to the coefficients. So if we have 1x squared, then our a would be 1. Negative 2x, then our b would be negative 2, and so on. This, one way to call this, or one name for this form, is factored form, where we've just broken down the x squared minus 2x minus 8 and kind of unfoiled it. You might have used FOIL as a memory device on how you multiply the x by the x and the x by the negative 4 and the 2, and basically it's just distributing twice. But that's undoing multiplication is factoring. So that's factored form of a quadratic. And another form, which is probably new, is called vertex form. And that one's going to look like this: x minus 1 squared minus 9. Okay, this one's called vertex form. And these three equations, they all look pretty different, but that's actually three different forms of the exact same equation. And a lot of times this happens like with lines. There are different ways to write the equation of a line. You could write a linear equation in y equals mx plus b form. I need to write this down right now. And then you've got slope-intercept form, y minus y1 equals that sort of thing. And you've got standard form. And there's different forms of the same equation, and that's what we're doing today with quadratics. Each one of these equations, which actually, like I said, is the same equation, the graph formed by a quadratic equation is a parabola. Okay, so if you graphed any one of these, or any quadratic equation, you're going to end up with a parabola. And a parabola is kind of a U-shaped graph. It could be opening upward, it could be opening downward, it can be really skinny, it can be really wide. And we will talk in depth about parabolas, but right now we're just kind of getting the hang of it. Anytime your a is negative, that's what's going to make the graph open downward. Anytime your a is positive, and when I say a, I mean the number out in front of x squared. So if we had a negative sign either here or here or here, then the parabola is going to open downward. We'll leave those off for now. Okay, that's a big fact about these. It's going to help you get from this equation to this picture. So the main idea today is, what does each one of these things tell us about the associated parabola? What can I look at from this equation and determine what info is being given? How can I turn this equation into a picture? You can always graph something by plugging in x values and getting the y values that go with them. Just an old-fashioned way to graph. But I would like to not have to do that and just see what info I can gather. So let's start with y equals x squared minus 2x minus 8, the standard form of this equation. Okay, so what we've already determined is that this thing opens up. And what else could we tell about it? You know, there's not a whole lot of info that I can get from standard form without actually plugging in some x's or just typing this thing into my calculator. One thing that's readily available is the y-intercept. So all I can really tell about the parabola that matches this graph is that it opens up and it goes through the point 0, -8. So let's start working on a graph. All right, it's kind of cool. Big dark graph here. So far what I know, just by looking at this one, it opens upward, it goes through 0, -8, 1, 2, 3, 4, 5, 6, 7, 8. This is a point on my graph. And from standard form, that's really all I can tell. Right? There's a lot of different parabolas that open upward and go through that point, but that's all I know so far. So let's move on to another form of the equation. We have x plus 2, x minus 4, the factored form. Same equation. So -4. What does this one tell us? I still know it opens up because neither of those x's are negative and there's not a negative out front of the first set of parentheses. But what you can tell from factored form are the x-intercepts. I can very quickly tell that this parabola goes through the points 4 and -2. Now you can tell those are the opposites of the +2 and the -4 that are sitting next to my x, all right? Because think about it, an x-intercept is what makes y 0. So if this 2 right here, or excuse me, if this x right here were a -2, then that set of parentheses would equal 0. And it doesn't matter what the other set of parentheses equals, the whole thing equals 0. So that's kind of why that's the case, but right now, most importantly, what we need to know, in factored form, take the opposites of those two numbers that are being added to x, and those are your x-intercepts. So I know that this parabola is going to go through -2 on my x-axis and +4. All right, so now it's starting to take shape a little bit better. All right, let's look at this final form of the equation. X minus 1 squared minus 9. And this is called vertex form. And that might give you a big hint of what we can tell from this form of the equation. Vertex form tells you the vertex. Now the vertex is, I call it a point, although it's not really sharp like a point. It's like the turning point. It's the minimum or maximum value of this quadratic function, this parabola, the highest or lowest. If your parabola is opening up, then this gives us the dip, the lowest point that it goes. And it's going to be the point 1, -9. Now, remember how this 2, we took the opposite, got -2? This -4 is +4, we took the opposite of those. The same thing goes with this x minus 1 in parentheses. X minus 1 gives me the x coordinate, and it's the opposite of the -1, it's +1. The -9 is not in those parentheses, and what that does is it makes it just stay the same. So the opposite of the number with x, comma, the y value, which is that last constant on the end, gives us the vertex. So this thing's vertex is 1, -9, which is right here. And it just kind of fits into the pattern. This was 4, 0. This was -2, 0. And each form of the equation gave us a little bit more info, and we've kind of created, a pretty decent outline. We know it's a U shape, we know it's going upward. Without actually getting more points, I can figure out a few more. What's called the axis of symmetry is a vertical line that goes through the vertex. So this pink line, which would have the equation y equals 1, x equals 1, that basically creates like this symmetry, the mirror image. So any point on one side, I can reflect over to the other side and get another point. Okay, so the point 2, -8, although it didn't come from any of my forms of the equation, I can get it pretty nicely, and that just helps me get a little bit better picture. So when it's all said and done, I've enough points to get a pretty good picture. Now remember, you can get as many points as you want. Plug in 3, 4, 5, 6 in for x and see what happens, see what y you get. You can do that all day. But I've got the highlight points here. I've got my intercepts, my 1y intercept, my 2x intercepts, my symmetric point, my axis symmetry and so on. Last thing, you're not going to be given every single form of this equation every time. So let's talk about how to go from one to the other. Now, if you're given standard, to get to factored form, you just factor the quadratic. Right? That's why it's called factored form. That's something you should have done before, and we will do a lot more of that in here. And we'll leave that to discuss in class. If you're given factored, and you need to get to standard, then you're going to multiply it all out, like I showed you earlier, sometimes called FOIL, sometimes not. So what about this vertex form? Let's start with the original, x squared minus 2x minus 8, and let's get it into vertex form. Start a new page for this. Okay, so putting it into vertex form, this is more about this new skill that I'm going to show you. You could find the vertex of a parabola really quickly with a calculator, or there are other ways to find it faster than this, but this is more about this process right here. Make sure you write this down. Completing the square is a process that allows you to come up with a perfect square binomial like this, starting with a quadratic expression like this. So if I want to go from standard to vertex, I need to figure out how to get this perfect squared trinomial, this binomial, this x minus 1 quantity squared. And here's how that works. From our original, let's kind of separate that. Let's go x squared minus 2x plus blank equals, minus 8, and then I'm going to put, well, I'll just leave that for just a minute. Here's how you complete a square. Think about this perfect square, x minus 1 quantity squared. If you were to multiply that out, you would write it down twice and you would multiply it out. You wouldn't just square the x and square the -1. It's a big no-no. You would do, you don't have to write this right now, I'm just kind of rambling. You would square the x's, minus 2x, which was minus 1x, and minus another x, plus 1. Alright? This 2 right here is double the -1. And this 1 right here is the -1 squared. So kind of working that process backwards is going to make us do this. To complete the square, separate the -8, take half of the b coefficient, the -2, half of that's -1. -1 squared is plus 1. So therefore, a plus 1 goes there. Right? That process, half of the b and then square it. Now, you can't just go adding 1 to an equation without changing it. All right? That's not legal. If you're going to add 1, that's fine, but you need to keep your equation balanced by also subtracting 1. All right? You can add 1 and subtract 1 to the same side of an equation and not change the equation. So what's the point? Well, the point is that now all of this can be written as that perfect square binomial, x minus 1 squared. The number that we got when we cut -2 in half, that's the number that goes in here with the x. Then the -8 and the -1 combine to make -9. And that's how you can go from standard to vertex form. And the usefulness of vertex form, again, is that it shows you the vertex really quickly. The vertex of this parabola is opposite of -1, and then -9 as is. You don't have to take the opposite of -9. Okay, so a quick review of what we've covered here. 3 forms of the quadratic equation. What they tell you, standard form really just tells you the y-intercept. They all tell you whether it opens up or down, if you have a negative out front or you don't. So standard form, right here, tells us the y-intercept is -8. Okay, factored form tells us the x-intercepts. They are the opposite of the numbers in there with the x's. Vertex form tells us the vertex. And those 3 things put together give us a pretty nice picture of what this graph looks like. Now, given any one of them, you should be able to get the other ones. Given standard, factored it to get factored, and you complete the square to get vertex form. If you're given vertex form, you can multiply it out and collect like terms and get back to standard. So that's our goal of the day. What do they tell you, and how to get from one to the other. So that is that for Unit 1, Day 1. Hope you enjoyed. Young out.